Alright, hello everybody. Welcome to an optional video. I just want to start off, I'm excited for this weekend. We're going to go ATVing and camp around Pismo Beach. So, hopefully I don't injure myself or anything. But if I don't come back on Monday, obviously I probably fell or something like that. Alright, so again, I won't respond to emails this weekend until probably like Sunday night if I feel like it, because I just won't have electronics. Alright, so let's start with this. I have two problems here, and one is from section 5.9, the other one's from section 5.6. One is simplifying complex numbers, and the other one will be a quadratic formula one. So I know I didn't mention it in class, but the quadratic formula, the reason why it's important is you can find zeros. Okay, it's another way to find zeros other than factoring. Okay, and it works all the time. Okay, 100% of the time. Right, so I'll start off with the complex number one, and then I'll do the quadratic formula. Alright, so anytime I want to simplify this is where you need to simplify. You have this piece right here where it's 5 plus I on the denominator, and what they want you to do is you want to multiply by 5 minus I, which is the conjugate, right? It's always A plus BI, well the opposite's A minus BI. Okay, and the reason for that is this is going to give us a nice, regular, real number. Okay. Now I can't just multiply by 5 minus I on the bottom and not do anything on the top, right? So what I'm really doing is I'm multiplying by the same thing on top and bottom. In other words, I'm multiplying by 1, right? I can multiply anything by 1 and it doesn't change anything. If I multiply this quadratic by 1, it wouldn't change anything either, okay? The only thing that might change in this one is that because I'm writing 1 this way, I can fashion this to look differently. Alright, so let's see what we get here. Now, I'm going to do the top via area model. I should put my question for that. I have 8 plus 2i, 8, so this is getting hard. Alright, 8 plus 2i, and for the other one I have 5 minus I. 5 minus I. Okay, so I'm going to split up this box. I have 8 times 5, which gives me 40. 8 times negative I, which gives me negative 8i. And for some of you guys that don't like the area model and you want to use FOIL, I'm not going to stop you or anything like that. It's just this area model thing works a lot better when you have like a trinomial, which would be like 10x squared plus 7x plus 4, and say I multiplied this by like x plus 2. The area model works a lot easier. Alright, so I'm going to do it for this. If you want to do FOIL, okay, that's fine, but I like this better. So this is 10i. 5 times 2i gives me 10i, and then 2i times negative I gives me negative 2i squared. Alright, so that should leave me with 40. I'm going to go ahead and simplify. Negative 8i, 10i, that should give me positive 2i. And then I have negative 2i squared, which should give me actually negative 2 times I squared. I squared is negative 1. Negative 2 times negative 1, positive 2. Alright, so this can simplify even more. I'm going to write it up here. 40 plus 2 gives me 42 plus 2i. And this one is number, I think it's number 32. Number 32 on section 5.9. So 42 over 2i all over. Now I need to do the bottom part. So I'm going to actually save time on this part. If you were to set it up, it would be like this. 5 plus I and 5 minus I. And you could do it like that. But I've gotten so used to seeing that anytime you multiply conjugates, it's called a difference of squares. What happens is the middle terms actually cancel out. These two things, like this negative 8i and this 10i, they cancel out. So I know 5 times 5 gives me 25, and that would be my top left box right here. This would be 25. Obviously, this negative I and this positive I, they'd be positive 5i and negative 5i. They're going to cancel out. And then lastly, you multiply these two, positive I, that gives you negative I squared. And I can go ahead and simplify this more here. So I have 42 plus 2i all over 25 minus negative 1 minus negative 1. And remember, because I squared, it's square root of negative 1 times square root of negative 1, so you get negative 1. Alright, so that leaves me with 42 plus 2i all over 26. Great, so here's what I can do now, and this is how the book actually does the answer. You can say 42 over 26 plus 2i over 26, and that's the same thing. Okay. Now 42 over 26, that can reduce down to 21 over 13, and then we have 2i over 26 that can break down to I over 13. So in other words, you end up with 21 plus I over 13. And that's it. Okay. Alright, so sorry the work is kind of messy, but I think you guys should be able to handle this part near the end. Alright, so for the next part we have the quadratic formula. And I'm going to go ahead and plug this in and see what it looks like into Desmos. 10, 7, and 4. So y is equal to 10x, 10x squared plus 7x plus 4. Alright, so if we look at this, we can see that it has no real solutions, right? It doesn't actually cross the x-axis. And hopefully you guys kind of remember some of the domain and range stuff. If you keep zooming out, this thing will keep going left and right, forever and ever, right? See, I can keep showing that. It can keep going out forever and ever. Granted that it doesn't look like it's getting farther out to the left and right, and that's just because these increments are getting pretty huge, like hundreds, negative 100. Alright, so the range, on the other hand, is from here all the way to infinity. And I'm not going to ask one that's super decimally or anything like that, but do remember domain and range. Okay, so I know that there's no two real solutions, nor is there one real solution. If it was one real solution, you would have like a point right here on the x-axis, and then later it'd go up like this, or it'd go down. Okay. Now, if it had two real solutions, it would hit it 2 times. In this case, there are imaginary solutions, so we have to find those imaginary solutions. So let's go ahead and find them. We have x equals negative b. So let's write our a, b, and c. A equals 10, b equals 7, c equals 4. Alright, so hopefully you guys know it. If not, look in the book. I'm not going to write out the formula again for you guys. So I have x equals negative b, so negative 7, plus or minus the square root b squared, well that's 49, minus 4 times a, which is 10, and then c, which is 4, all over 2a, which would be 2 times 10, 20. So that should leave me with x is equal to negative 7 plus or minus the square root of 49 minus 80. No, 160. 49 minus 160. 49 minus 160, 110. Should be negative 111. Okay. Yeah. Okay, so negative 111 all over 20. Now the last step here is that I need to get rid of this imaginary number part. See that it's negative? I can't have that, so I need to change it to imaginary. So the way I'm going to write this is x is equal to negative 7 plus or minus I square root 111 all over 20. Now you could even like say that you can write this in 2 ways, which would be that you get x is equal to negative 7 plus I square root 11 or 111 all over 20, and there's one solution, and you could box that up. And the other one would be x is equal to negative 7 minus square root or minus I square root 111 all over 20. And that's the other way you could write it. So I'll take both. You can either write out both solutions, or you could just do this one. To me, it doesn't make a difference. If you might get someone later who's really nitpicky about it, maybe it will. Both work for me. Okay. All right. So that's our video. There's A and B. I think A covers a lot of good things. You can multiply complex numbers, as well as we are simplifying with the conjugate. You're adding i's, like here, negative 8i and positive 10i. So I think that covers most of 5.5 and 5.9, and this covers 5.6, the quadratic stuff. Just recognize that you get two imaginary solutions, right? Just like in the Desmos, anytime it's above the x-axis and it isn't going to hit it, those are imaginary solutions. Okay. All right. Well, have a good weekend. I'll see you guys on Monday, and then we'll have a test on Wednesday. So I'll probably give you guys like a Zonk review, just work through concepts, and then Wednesday we're going to test. I might give you guys 10 minutes to ask me questions, and then give you the rest of class to do the test. Okay. All right. Have a good weekend.